guys, this is Wojtek from Jolly Monster Studio, and today we're going to take a look at how to create elevators, specifically things that move along a spline, which you can turn into elevators, doors, escalators, any kinds of different sort of traversal type path. We're going to trigger some overlap events. We're going to include some timelines, and one other thing that I'm introducing as part of these new tutorials is blueprint versions of all of our content, and this is exclusively through Patreon. A number of folks have been asking me, hey, how can I help and reach out and sort of support the channel? And I could come up with a clever way of ensuring that you get a fair sort of kick at the can, but also provide you with some additional content for your hard-earned bucks. So we have these blueprint tutorials that are going to be available on Patreon and then moved into the YouTube channel at the end of the year, so everybody can get a feel for how to convert C++ objects into blueprints and vice versa. So on the right hand side here we have the C++ classes, and on the left hand side we've got the blueprints, and as you can see they are almost identical. They do share some base attributes, and yeah, we're going to get started on that. So check out the C++ content coming up. Okay, so let's get started. The first thing we're going to have to do is create a new class for our new actor. So we're going to click on the C++ classes folder in our editor, right-click on the right-hand pane and say New C++ class. The parent class we're going to pick for our new object is going to be an actor. And why an actor over a pawn or a character? Well, we're not going to be interacting with this thing through the player controller. We're not going to have any AI behavior. It's just going to be a simple prop within our level that the character can interact with, or perhaps other NPCs. So let's go ahead and make the actor the parent class, and let's give it a name. And we're going to call this a moving spline actor. And you will notice I already have this class created because I was testing this out earlier. So let's drop it into our props folder just to make sure we start organizing our code a little bit, and click Create Class. Okay, so now that we have our class created, let's go ahead and start decorating it with the properties that our actor is going to require. So we're going to need a spline component. We're going to need a mesh that's going to move along that spline component. And we're going to add some sort of trigger object that allows the player to basically initialize this whole nonsense to start kicking off. So let's go ahead and include these properties. Now I like to separate my properties from my methods just within the header definitions. It's a little bit easier to read, makes organization just a little bit more tidy. But you do you. So we're going to create a new property, and this is going to be visible anywhere and blueprint read only. Let's give it a category of spline, and we want to make sure that the meta for private access equals true, and this is just going to allow us to view the various properties within the editor for that particular component. So this is going to be a uSpline component. Spline component name. Make sure you include your header definitions. This particular one comes from component spline component, and you'll notice my IntelliSense, my autocomplete is a little bit more robust because I'm using the ReSharper extension within my Visual Studio 2019 IDE. Second property, actually, you know what? Let's just copy the same definition. This is going to be our static mesh component. That's going to be the thing that moves along our spline. And lastly, we need to include the trigger for this particular moving entity. So again, let's take the property definition and let's bring in a uBox component. And that's going to be our trigger component. Again, make sure to include the headers. Now, with our header definitions initialized for these properties, we also need to go ahead and instantiate these objects within the constructor. So let's go ahead and crack that open. One thing you may notice is by default, control clicking onto the constructor didn't take me into the definition, because when we auto-generated our C++ class, as well as the header, the auto-generation tool dropped in the wrong folder, or put in the wrong folder definition. So it's saying, hey, from the root, go into props for that header, but we're already in the props folder, so you just need to ensure that gets removed and your compilation problems go away. Now, if I control click on the constructor, I get brought in directly in here. So let's go ahead and bring these three objects to life. So we're going to say for our spline component, we're going to create a default sub-object with a type of U spline component. And this is going to be called our spline component, for lack of a better definition. Always make sure to give it a name. You can always change this later just for, again, organization and cleanliness. Spline component, we're going to attach it to the root component. Or actually, sorry, not attached to, setup attachment. So this is going to become the root object of our blueprint when we're looking at it, since there is no root component currently. Then we're going to define our mesh component. And again, we're going to create the default sub-object definition for this. Static mesh component. There's our mesh component. And we are going to set up the attachment for this particular element to hang off of our spline component. That way we're creating this nice little hierarchy where it's spline, mesh, trigger. And our trigger component, same thing, create the default object. Box component, give it a name. And then we need to ensure that it, again, hangs off the mesh component, just from a pure sort of hierarchical standpoint. So let's go ahead and click compile and make sure everything works. So with our newly created class, we're going to go ahead and create the blueprint just to see what it looks like before we go too far ahead down our tutorial. So in the tutorial resources folder, let's go ahead and create a new folder called props. And inside of this, we're going to create a new blueprint based off of our new moving spline actor. And it's right there. So let's give it a name. It's going to be BP elevator. So we're going to make a very simple object for right now. That's just going to move up and down and let our character reach some hard to reach places. So let's get rid of these actually stairs while we're here. Let's get rid of this thing. And let's take all of these objects here and scale them up just a little bit so it's much harder for us to get up there. Okay. And I'll recompile the lighting in a bit, but that's what we're going to try to get up to. As you can see, our character is definitely not going to be able to get up there by himself. But our elevator is going to help. So let's take a look at this elevator object. And you can see we have our spline component, we have our mesh component, and we have our trigger component. So let's set a mesh for this, and I'm going to use a shape. Let's just do a cube for now, and I'm gonna squish this guy down. And we'll move him down just a little bit. Make the trigger component on top of the mesh. And then we're going to scale this guy out a little bit this way. So we have this little platform, and when the character steps on it, it should start doing something. Let's see what this looks like relative to our level. Let's pop that in here. Okay, let's take a look. All right, so there's our elevator. We may want to make it a little bit bigger, but this is going to do for now. So let's go back to our C++ code and start adding some properties and definitions that are going to make this thing actually move. So with our blueprint operational and showing the right components, let's go ahead and start adding some additional properties that are going to make this thing move along the spline. The first thing we're going to want to include is a timeline. And the timeline is going to be the crux of a lot of this movement, as it's going to help the translation code that moves the mesh along the spline. We're also going to leverage its finish timeline function callback to perform some additional events. And that's going to be sort of the big chunk of work that we're going to put into this object to actually make these things move along. The other thing we're going to have to include is a curve float or any other sort of linear-based definition that we can inject into our timeline that's going to actually represent the duration of the timeline, as well as the potential curvature of that duration that does things like make the elevator slow down and speed up at certain different points in time within the execution. So let's go ahead and create this first private variable, fTimeline. It's going to be our movement timeline object. Make sure to include the headers. This one comes from the timeline component in the components folder. And we're going to add a new U property. And it's going to be edit defaults only, read only, category is Spline, and this is going to be our curve float object, and then we're going to call it the movement curve. So like I said, the timeline, which you can navigate into if you like, has all kinds of different properties: the play rate, the length, am I playing, am I reversing, am I looping, and we're going to use a bunch of these different attributes to kind of move around the timeline. One other thing we also need to consider is we have a trigger component that's going to be ensuring that the player gets captured as part of the interaction with this particular object. So this guy needs a couple of methods assigned to him, one for the start of the overlap and another one for the ending of the overlap. When the player leaves the platform, we want to capture those movements. The timeline is also going to need a progress function. So hey, move along the spline, or do whatever. It's going to need a finish function. So on complete, and then we're probably going to need another function somewhere along the way, just to kind of start tidying up some of this stuff. But let's go ahead and define a couple of these things before we go down too far. So the first function is going to be our process movement timeline. Let's make this void on end movement timeline. So this is going to execute at the end of our timeline execution. And then we're going to need a few more functions for that trigger component. Now, the trigger component, let me start diving into this logic here. Actually on the begin play. So we have our trigger component, and it has various callback functions that we can put in there specifically for these overlap events. So on component begin overlap, we want to add a dynamic call to a function that we have within our system, or within our header file rather. So we pass in this as ourselves, and then we would make a reference to moving spline actor, and then whatever the method signature is. So we don't have these methods yet. I'll show you real quick how you can get the signature. So if you go to the on component begin overlap, you'll notice it points you to this struct here. Declares this dynamic signature, and there's its name, as well as the beginning of the parameters that actually go into it. So I'm just going to steal all of this stuff, hop into my header, and say, view function, and this is going to be our trigger begin overlap method. There is the signature, and the only thing you have to do is just remove these additional commas. And this is for all of you lazy developers who don't remember the signature off the top of your head, but want to get at it pretty quickly. So that's my lazy man's way of getting at it. So that's the begin overlap, and then we can do the same thing with the end overlap. So let's say trigger begin overlap, and there's our dynamic callback definition. Trigger component on component end overlap, dynamic. This and the same object definition, trigger end. Okay, so same thing, control click on end overlap from your object definition, takes you to the signature, which takes you to all of this stuff. And then we can just grab these parameters, take those, and create our function here. Function void trigger and overlap, pass in our parameters, and we should be good. There's that. Okay, so these are sort of the main functions that we're going to be working with for the next little while. Let's go back into the C++ file and make sure we generate definitions for all of these methods. Again, I am being lazy and using resharper to kind of help me automate the method signature definitions, but feel free to type all of this out or copy from your other projects. Now that we have this defined, we are going to just recompile, make sure everything runs, and then start fleshing out the logic within these methods. So we're all recompiled, and our object definition, our elevator, our blueprint within the editor, should now have a new property for the movement curve. We don't have this yet, so let's go ahead and create that and assign it to our object. So if you right-click within the props folder and go to miscellaneous, you will find the curve action, and we're going to create a curve float. So this is going to be the movement curve. And if you open up the curve blueprint definition, you'll see this sort of scary looking thing. I don't know what I'm doing, what's going on here. But essentially, this is your timeline. This is the beginning of your timeline, this line here, on which you can right click and say add key. The key is basically the points of the curve at which you can either speed up or slow down or basically readjust the shape of that curve definition. So if you click on your keyframe, you'll notice in the top left hand corner, you have these two little windows. One is the position and one is the time. So we're at 0, 0 with our single keyframe. That's the beginning of our timeline. Let's go ahead a little bit further down and then add another key. And this one's going to be 1, 1. So you'll see basically what we just did is over 1 second of execution, we went up by 1 float value from 0 to 1, right? Pretty straightforward. If we want this duration to be longer, we would obviously take this value and maybe move it at, let's say 15 seconds, right? And that basically says over 15 seconds, we gradually go up to this 1 value. So whatever 1 is meant to represent, it will take 15 seconds to get there. Okay? So this is our simple curve, and we're just going to set this back out to 1 and assign it to our blueprint. So there's our movement curve. Okay, let's go back to some C++ code. So going back to our C++ class, let's start defining the signature for the begin overlap method. This is the one that's going to get called when our player steps on the trigger box. So to do that, we need a timeline float, and this is going to be the progress function callback. So we are going to bind this against our object, and then the process movement timeline method name. Okay, and on our movement timeline, the actual timeline object, you can say add interrupt float, which takes in the curve parameter we just added, the float curve, as well as the timeline float method signature that it's going to pass that value onto. And I'll show you, I just made one little mistake that I caught here, but let's add in our movement curve and then our progress function. And remember how I was saying you can find the signature definition for a lot of these callbacks by control clicking on their signature definition. You'll notice I'm missing the float as an input parameter to our process movement timeline function. So let's give it a value, and then going back to our CPP file, let's make sure that gets passed in as an input parameter as well. So yeah, just always make sure to check the signature for these callbacks that you're using. Now the other callback we're going to do is on timeline event, and this is going to be our timeline finished function. Finished function, we're going to bind it to this and text on and movement timeline. And we also need to assign it to our timeline set finished or set timeline finished function, and then we just pass in the on timeline finished function. Okay, so this guy will get called at the end, and we'll have some logic in here later on. Cool. So player goes on, we instantiate these dynamic methods. We also want to say movement timeline we want to set the length mode of the timeline to be basically the last keyframe. So if we have many keys within our timeline, we always want to stop on the last one. And we can probably say play. So he steps on, everything gets set, and we start triggering the play execution. Now, the movement timeline doesn't work just by itself. So in your tick, you need to ensure that we call the isPlaying check, just to make sure that we're not inadvertently calling the tick when it's not requested to be played. And then we say movement timeline, tick timeline, and we pass in the delta time. So this is actually going to trigger everything when our player steps on the trigger box. Now, to move the mesh along the spline, let's start fleshing out this process movement timeline function. Okay, so in order to get this going, what we need to do is first we need to obtain the length of spline points, or how many points along the spline there are. So it's going to be a just float. Spline length, and it's going to be based off of our spline component with spline length. Cool. I'm just going to make this constant because our spline's not really going to change at runtime. It's going to remain pretty static within the level. Second thing we want to do is start capturing the location and rotation along each point within the spline. So let's go ahead and create a vector. So current spline location and spline component. So we want to get the location at the distance along the spline. The distance being the value, so what we're passing in, times the spline length. And the coordinates are going to be world coordinates. Okay, so that gets our current location. the rotator is going to get us the rotation of the mesh. So again, let's get the rotation at distance along the spline. It's going to be our value times spline length. And we're going to make this world specific as well from a contextual standpoint. So let's just move this over here and maybe, actually we'll leave this zoomed in. Okay. Once we have those two values, we can go ahead and set the position of our mesh along those two definitions. So the way you want to do it is you would say mesh set, mesh component set world location and rotation. There we go. So first parameter is the location. So current spline location and current spline rotation. Okay, so we come in here for every tick and every spline point. We get some of these values, we figure out where we are in the world, and we move that mesh along that particular path. So let's go ahead and compile and make sure everything is operational before we go too far. So going back to our editor, let's take a look at what all of those changes equate to within our actual elevator. The one thing we're going to do first, just before we go too far, is open up the movement curve, and we're going to change it so it's not 1 second of duration, because that's going to be really quick. Let's make this a little bit longer. So I'm going to make it 15. And as you can see, what we're getting is a very slow increase to that one value over 15 seconds over time. Cool. The other thing we're going to do is adjust the spline direction. So we want this elevator to go up. And as you can see right now in our blueprint, the spline point, the first one, is actually facing forward 100 points. So we change that to be 0 and 100. We will now get it to move upwards. And for right now, we're just going to do this. And let's see what our elevator does. So as you can see, we're moving along our spline. We're gently rising up over 15 seconds. And I'm sure if someone were to count it, it's exactly that or thereabouts. And then we get to the top. It should just stop. And there it goes. So that's our very simple elevator. As you can see, it doesn't go down, doesn't do much of anything outside of just kind of gently lifting up from the ground, from the very first point, which is a little bit lower in the ground, so we can raise that up. That's okay, and then it gently goes up. If we now adjust our curve back to 1, 1, we go back to our game, you can see what that effect is like. Very snappy, just, 1 second duration. Let's get a couple of these guys going, just so we can see what this looks like. Cool, all 3. Now, if we want to add additional spline points, and this is pretty much what we want to do with a lot of these objects, let's take one of these guys here, and if you click on the spline point itself, you'll notice you get another widget, and that's for changing its orientation. So we can do something like this, where we drag it just all the way up to the top. So we can do that. And over 1 second, we have an elevator. Additionally, we can take those points and we can move them, in any sort of direction. So, out here, we can also rotate them the way you would in order to create different sort of curves to the spline. So let's do this. Let's create a little flat curve, so it should go up and over. And then if we hold down the Alt button, you can add additional spline points. So you just keep holding down Alt and dragging on the on the widget, you'll notice everything kind of moves around. So now we have this weird little spline going, and when we get on our elevator, it's going to follow it almost exactly. But you can see one thing we have a problem with is the orientation of the elevator is mimicking the orientation, the rotation of the spline. So when we were moving things around, actually changed its rotation. So we'll fix that as well. And then we probably want to include a return command to our elevator. So when we're off the elevator, you can go back and then we can retry it and keep messing around with it that way. So let's go hop back into the code and start cleaning this stuff up. So getting back to our code, let's implement the return statement for our elevator such that when the player character gets off the elevator component, we can return back to its original position. So going into our trigger and overlap method, we are basically going to say if our movement timeline is not reversing, so if we are not already in the process of moving it back to its original point, we're going to say movement timeline reverse. So we just played the timeline back to its original keyframe. So that's going to get it to go back to its original spot. And the other thing we want to do is ensure that the rotation of the object we're moving around remains constant, and we're not actually going to drop the player off the thing as it's moving around. So what we're going to do here is we're going to say current spline rotation, and this is in the process movement timeline method. We're going to take the pitch and we're going to set it to 0. So essentially, the platform should always remain flat wherever it goes. Let's recompile and see if this worked. Okay, so going back to the editor, let's take a look at our changes just to make sure everything works. So there's our single elevators, and you can see they let me go up and down. The trigger box is maybe a little bit too close. So let's fix that real quick. But you can see our elevators coming back as you would expect when the character leaves the platform. So that was one of our fixes. The other fix was ensuring that the rotation of this particular elevator remains as is. Now this one, whoa, what is going on here? There we go. Okay, so because the elevator is moving back so quickly, my character wasn't running fast enough off the platform, and I was doing some weird collision detection. So we just jump. You can see how quickly it goes back. Let's go back to our curve and let's make this, sorry, let's say 5 seconds. That should give us a little bit more time. There we go. Sorry, it was just a little too fast. There's another problem that you might be able to observe. Our platforms they're starting lower, but then when we get on them and they go back, you'll notice they return to the first starting point of the spline. So what we need to do is on start, on begin play, ensure that the mesh aligns with the first starting point. So we're going to fix that too. We have a reversal working correctly. We still haven't gotten up to the top, so let's fix that. Let's actually take these guys, slide them over. This guy over here. Let's take our spline point, move it all the way up. Let's make sure we can get on top of our little platform here. Looks pretty good. And then goes back down. Okay, so the spline point could be just a little bit taller. So yes, we're going to fix the mechanic for it to align with the initial starting point. That's a little tweak we need to adjust. We have them going and returning on reversal. We can also add a couple of other options for resetting to the beginning. So if you want like a mining cart that goes, from the left part of the level to the right part of the level, and then it respawns back and just kind of keeps going in this sort of loop without actually introducing a secondary spline, we can create that, as well as a mechanic where um, it ends up returning back to the original place you came from automatically, not waiting for the player to actually initiate that return. So let's go back to the editor and make some of these code changes. Okay, so going back to the code, let's go in and put in a couple of additional properties that let us control the blueprint a little bit more freely with all these other sort of variables that we're going to be introducing. So let's add in another property into our header. And this one's going to be for auto activation. So do we want this thing to start running on its own rather than based on player interaction? So we'll say it's a Boolean, be auto activate to wait. So we'll set that to false. We're also going to introduce another property for when we hit the end of our timeline, immediately trigger the reversal of it. So it goes back to where it came from. And the player has to re-trigger that event for it to go again. So that's going to be another Boolean, be reverse on end timeline. And another one that says restart to the beginning rather than reverse. So we restart on the end of the timeline. Now you will notice that these two properties are mutually exclusive, right? So I can't reverse and restart at the same time. So U properties give us the option of introducing meta definitions, edit condition specifically, where we can say not this property. So where we're basically saying, hey, this guy can only be set to true if this guy is not set to false. And likewise, we can do the reciprocal on the other side, but where we say, hey, I can only restart if I'm not already reversing. So that's a cool little trick that gives you the flexibility of ensuring that your blueprints are restricted for the end user, because, in certain cases you may have very complex conditional logic and you don't want that stuff to be always active because it will cause all kinds of shenanigans and issues. So we have our properties, auto activate, reverse, and restart. Let's go into the CPP file and start implementing some of this logic. So first we're going to say if B is B auto activate, then we say movement timeline play. So on begin play, we're going to immediately kick it off if auto activate is set to true. Now, the other thing we wanted to do is ensure that the mesh was positioned correctly within the location of the first spline point. So to do that, what we're going to do is we're going to say mesh component set world location. And this is specifically on the Z in our case, but you may want to just immediately set it to wherever that point is. So we can simply say, f vector spline location equals spline component get location at spline point 0 and we want world space. Okay, so we want to set that location to the world location of our mesh. Let's make that a const because that's not going to be changing. Okay, so that on begin play should immediately everything or get everything aligned, and then we won't have the little height difference. Okay, cool. So one thing done, the auto activate is working. Now we want to say when our movement is finished, do we want to restart or do we want to reverse immediately? So on end movement timeline, this is the method that we actually haven't done much with yet. Let's say, hey, if b reverse, else if b restart, we can make a couple different decisions. So on the reverse, we're going to say movement timeline reverse, and on the restart, we're going to say play from start. So that immediately takes it back to the first keyframe, and off it goes. So that's going to be at the end of that. Let's recompile and see what these changes look like. So back in the editor, let's take a look at what our changes look like. So you can notice we now have additional properties on our blueprints. If we crack this guy open, we have our 3 auto activate, reverse, and restart. And if you notice, if we check these booleans, they are mutually exclusive and they will turn each other off. And this is just another little safety precaution for ensuring your blueprints are good for designers and artists and other folks to interact with. Cool. So let's go ahead and adjust our timeline. Let's maybe make it a little bit speedier. Let's go for 3 seconds. And then going back into the level, let's do a couple of things. So, you know what? Let's make this guy auto-activate. Let's make this guy restart on the end of timeline, and this guy reverse. So, let's see what happens. There's our elevator. Boom, goes back down automatically. Get back on. There it goes. Cool. Okay, now this guy did not auto-activate, but he still seems to be doing his regular business. Also, our rotation is looking good. You'll notice when we get to the end, nothing happens. There's a little bit of glitching when this guy collides, but we don't have to worry about that for right now. And this guy should reset when he reaches the top. There he goes. So 2 out of 3. We got to figure out what's going on with the auto activate. So let's jump back into the code and do a little bit of debugging. So back in the code, let's take a look at why auto activate was not behaving correctly. So the boolean in our begin play is set to true, and we say movement timeline play from start. And on the end movement timeline, we do our flips. So these guys are working, right? So on end movement timeline, which is called within the begin overlap. And here's the problem. As you can see, we initiate the functions that move and end the timeline within the trigger begin overlap rather than within the begin play. So in the begin plane, where I'm trying to make use of our movement timeline, nothing is actually happening. So all I'm doing is I'm taking all of that logic from our begin trigger overlap, and I'm just going to move it right up here into our begin play. So when our object gets instantiated, we make all of the appropriate assignments, and then we can say, okay, auto activate, cool, our thing is initialized, it's going to move it across the timeline, play from start. Let's recompile and just double check that this is working correctly. So actually, before we go back to the editor, one thing I did forget to mention to you guys is I went ahead and modified the properties in our header from edit defaults only to edit anywhere, and that allows you to modify these properties within the level editor when you actually drag your blueprints in there. Just one little thing I forgot to mention earlier on. Back to the editor. Okay, so back in the editor, let's see what our, oh, and it's gone. So auto-activate is now working correctly since we moved it into the begin play logic, or rather the movement timeline instantiation logic. We shuffled around. So that's great. Let's make sure it works for all of our guys. And this is what I meant about the properties. So if you just go ahead and change that to edit anywhere. And there you go. Everybody's running on their own, and the reversal is doing its thing, and the restart is also doing its thing. So that's great. Let's go ahead and make this platform restart on end. And there you go. Look at that. And if I stand on it, it should just pick me up and then take me away, and then I come back with it. Because it resets it so fast, my character has no ability to get off it too fast. But then if I get off it, it goes back to normal. There it goes again. Boom. Cool. So you can see how this is potentially the beginnings of flying cars in your level, flock of birds, elevators, opening doors, what have you. Additionally, I'm kicking off our Patreon specifically to support the blueprint development of all of these tutorials. So I've been getting a lot of requests from folks saying, hey, how do I run this in C++, or how do I take this blueprint function and break it down into C++/blueprint, or how do I just do this in blueprint natively? So what I've gone ahead and, because a number of you also asked, hey, how can I help support this channel and grow the content, I thought, hey, why don't I create some blueprint tutorials on the Patreon? If you guys want to throw a buck or a couple bucks towards that, that'd be great. Otherwise, we're going to continue releasing all these C++ tutorials for free, as much as I can possibly develop. And at the end of the year, we'll get all those blueprint tutorials out on YouTube for everyone to see. But I thought this would be an honest way to kind of have you guys support the channel and make it grow, and hopefully provide you with a lot of educational content in the near future. So thank you for checking out this tutorial, and see you guys next time.